I heard Tuesday. Is that when the test is?
Alright, the question is just so crazy. Like, how are you supposed to even understand what they're asking you? Number 11, for approximately what values of x can you replace sine x with x minus x to the third over 6 with an error magnitude no greater than 5 times 10 to the negative 4? Give reasons for your answer. What, you didn't get this problem?
Wait, can you start it over?
Why can't they just say, here's the function, go to this degree, what's the error?
Right. Which is usually what they are going to do.
Yeah.
It usually is what they are going to do.
Usually until your test comes around.
Yeah, and then
On Monday.
On Tuesday.
What they're trying to get you to see is that this is actually the series for sine of x. The sine of x for series, or the series for sine of x is x minus x to the third over 3 factorial plus x to the fifth over 5 factorial, blah, 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 blah. This is actually the series for sine, and it's only the first two terms, because 3 factorial is 6. So what they're giving you is the sine of x, and they're saying if we take its series and we just take the first two terms, how do I know it's sine? Just because I know. So, well, I mean, because they did say sine x, I don't know.
You said how do you know this is serious?
Because it's a subtraction of two things, and they're the first two terms of sine, and they're telling me I have sine x. That's the only way I
How do
know.
you find the 13 times?
Of sine? You have it memorized, or it's on the yellow sheet, or you can go figure it out.
So, when we take the actual exam and some random question comes up like that, how are we gonna know?
You're gonna have a little bit of experience and say, oh, you know, I kind of remember seeing this. You're gonna try to throw down stuff on a paper that sticks, and you're gonna realize it's only gonna be a point or two. Right, it says sine x. It's talking about error. Think about the only time we've ever done error is with series. So make the connection between this thing that they're giving you and sine x. This is the series for it. So, you know, that's the best you can do. Anyway, they want you to show that the error is less than that, right? Yeah, that the error is no greater than this. So I'm like, all right, let me go get the error formula. And the error is we take the next terms through. Now, how did I know it was fifth and not fourth?
Because of the sign.
Because I'm not going to have a fourth one because I'm all odd numbers anyway. So the next term's going to have the fifth, and I'm going to have it's centered at 0. So I'm going to.
On the answers, you put fourth order for.
Okay, I haven't really talked about the staffing. This is really a fourth order polynomial because the highest degree here is 4. It's just a 0x to the fourth. So technically I could call this a fourth order polynomial because I have a fourth in it. It's just a 0 coefficient. I know.
No. Why can't you just say it's 3?
Because I don't have any degree of fourth. I could call this a third degree or I could call it a fourth degree.
It's a 4th degree.
But if it said the first two terms, how would
This does not say it. I said that.
you just wrote it?
I wrote that. Doesn't say the problem. Okay, so they're giving me the first two terms. I can consider that to be a third degree or fourth degree because my fourth degree has a 0 coefficient. It's not there. So if I'm going to look for the error, I'm going to start with like the next term, which for me is fifth. I'm going to start with the fifth derivative because my fourth one is just 0. So here's my formula for the error. So if you see all my answers, I went down to the fifth derivative. I'm not going to take them all right now. The fifth derivative is cosine x. Evaluated at x equals 0 is 1. So when I take my remainder formula, I just have to put 1 in for the fifth derivative times x to the fifth over 5 factorial. And they want my error to be no bigger than 5 times 10 to the negative fourth. They're asking me to find the value for x that's going to ensure that that happens. So I just went through and solved this. And I got x, as long as x is less than or equal to 0.5697, I'm not going to have an error bigger than 10 times, or 5 times 10 to the negative fourth. I'm sorry, it just sucks.
Is there any problem with that?
No.
And it's plus,
Be honest.
it's like negative and positive, you can know.
Oh,
Nope.
why did I do that?
Keep going.
Going? Absolute error.
I don't think it really matters. I
Zach,
think I
you're
did it
getting
because
better.
I could have plugged in -1 here. I could have had a plus or a minus, because cosine could be plus or minus, kind of like we did in that example in class. So that's the idea. You're not really going to see it. I shouldn't have given such a hard problem. Let's see, number 13. Was it any easier? No, it's not. How about 15?
Just not even take this test.
What, can we just go over? Can we do it?
I want to skip to 15. Let's skip to 15 because 15 is going to more replicate what you might see. I told you weren't going to like series.
I like learning roots.
Are those new shoes?
No.
Were those the same shoes that you showed off to the camera the first
It
time?
is.
Saskia,
Probably
first
excited.
favorite?
Okay, use the approximation. E to the x is approximately 1 plus x squared over 2. That should scream out to you. That's the series for e to the x. It's the first 3 terms of the series for e to the x. Alright, that is used when x is small. Use the remainder estimation theorem to estimate the error. So this is asking you to find the error. When the absolute value of x is less than 0.1. So basically it's saying when x is between negative 0.1 and positive 0.1, find the error. This is the exact problem we did in class, except we didn't use e to the x, right? I don't remember what we used. But this is asking for the same thing. Find the error when the absolute value of x is less than 0.1. So when x is between negative 0.1 and 0.1, find the error. So what you need to know is, what degree series do we have? 2. So my remainder, when I use that formula, is going to be the third derivative at c times x to the third over 3 factorial. Do you get why? It's the formula for the remainder says we're going to use the next derivative. So if my series goes up to a degree of 2, my next derivative will be the third one. Times x minus a, but this is centered at 0, so x minus 0 to the third over 3 factorial. Get that? This one should be gettable. A lot easier than the last one.
Yeah.
So the third derivative is e to the x. Do I want to plug in 0.1 or negative 0.1?
Negative.
Is it?
What did I do?
No. If I plug in e to the negative 0.1, that's 1 over e to the 0.1. E to the 0.1. I get the calculator.
Do you want the biggest error?
The biggest error. E to the 0.1. Yeah, I graphed it. Is 1.105.
Is this a calculator test or no calculator test?
Both.
Can we just like
0.904. Okay, so this one's bigger. I actually did a